if it is compatible with all known quantum mechanical
Yes,
examples, then you
yes.
would just say, well, why not just, why is this
Oh, well,
Yes,
yes,
so,
right,
to
so
me,
that's a good question.
to
So
me
there
this
are-
is to do with history in the sense of history of the field.
So this is related to this afternoon's talk, I think, which is the measurement problem. So you'd like, that wasn't mentioned at all, and I don't know if we should, but maybe just say one word about how the measurement problem appears. It's related to the recovery of classical behavior for macroscopic objects. So with some schemes, you may not be, any scheme will give a consistent definition of what are the primitive coevents, but then we have to ask whether they resemble the real world that we know. And in the real world, we don't see, in some sense, interference among macroscopically distinct events. And then the question is, does the scheme tell you that? In other words, suppose I do an experiment and it has two possible outcomes. And suppose each one of those outcomes is an event. So, the pointer could have pointed this way, or the pointer could have pointed this way, or this detector registered, or this detector didn't register. Those are two events that could happen. Each one of them consists of a large number of histories. Suppose that the support of the co-event contained histories from both this outcome and that outcome. Then we would have to say, either we would, depending on the language, we would either say, in this way of talking, we'd say neither one happened, or you might like this language to say that both happened or something. But neither of that corresponds to the real world. In the real world, this one happens and this one doesn't happen, or vice versa, this one happens.
Classically.
In the macroscopic world, where these two events are outcomes of experiments, we never find that reality is represented by some kind of blend of this outcome of the experiment and this outcome of the experiment. So in order for this whole thing to succeed in solving the measurement problem, it must produce that result. With the multiplicative scheme, there's a theorem that will tell you that it does reproduce that result when you limit yourself to records. With some of these other schemes, it's not obvious that it will get the right result. So there are that's one example. There are other physical requirements that you might put related to causality. I won't even mention now. So there are very, very physical requirements that you would like the scheme to satisfy. And that's the rough guide. And beyond that, we have no more than a rough guide, I would say. We don't know a deeper principle that'll pick out the exact scheme at this point.
As an example of this Cochran-Specker, there's a Cochran-Specker argument to show that if you had a realist interpretation, that you would basically come into contradiction with standard picture of quantum mechanics and therefore with experiment. It's a complicated setup, but essentially the way that this gets the multiplicative scheme actually can get around it, so to speak, or to satisfy that without having to, it doesn't violate any experimental, anything that you could have, if you try to realize this in the lab, is because of the fact that rather than talk about fine-grained histories, you have these primitive coevents could be collections of histories. So the definition of realism has been also generalized from the classical definition of this. And so that's another example where the multiplicative scheme works really nicely there. So this is, I'm just saying that historically in the way in which this field has progressed, there seems to be more and more evidence in some sense. Although there are also things which are perhaps unpleasant about it, but they will not contradict. So far, we haven't found any contradiction with experimental things. And
yeah, I have to tell my joke again. I told to some people yesterday afternoon, which is it really true that in the macroscopic world we see classical logic? So the kind of thing that can happen here is that A doesn't happen. Here in this case, it's A doesn't. If you ask, did A happen? The answer is no. Did C happen? The answer is no. Did A or C happen? The answer is yes. Now that we normally think can happen, but we're not familiar. We think we're not familiar with that, but actually, I'm myself quite familiar with those situations in everyday life when it comes to house keys. So, so let's consider the statement, my keys, I'm looking for my keys. I know that I've left them in my house somewhere. So A would be, the keys are in the bedroom. B would be, the keys are in the kitchen. C would be, the keys are in the living room. So did A happen? No. I didn't find it there. Is it B happen? No. Did C happen? No. Did A or B or C happen? Which means the keys are in the house. Yes. Right? So I think everyone has encountered this situation. At least once.
While is getting worried.
What?
So that's a joke, but it's partly serious. I'm not sure that we know absolutely that classical logic applies to the macroscopic world. Yes, I love that. In that case, there's a classical solution to it.
That is also a very strong argument against extra dimensions, because imagine how difficult it would be to find your keys.
Yes, if we looked at 5 dimensions.
If you live